Hello everyone, this is Ashish and welcome back to Spacecast. Today we are going to continue a few of the things that we started in the last Spacecast that is related to James Webb Space Telescope. We have formed a community in which I got a lot of questions, and also I got a lot of questions down in the comment section. You're wondering about how to join community. It's a WhatsApp group, it's a small group. We discuss, people put questions over there, and whatever questions there are, I make sure that I address them over here. It's a fun way to have a great discussion, good interaction. More about how you can join that later. And I also want to specifically talk about the Russia-Ukraine crisis, which has become a crisis for my life as well. Because, see, sometimes I regret highly that I studied World War II so much. I shouldn't have, because now it has made me paranoid. And when I see even a tiny war, now I'm not saying that that is a tiny war, it's probably the worst war that has ever taken place after the World War II in Europe. But when I see anything over there, man, I start losing sleep. So honestly, I've not slept properly for the last 2 nights because of following that news way too much. So it's not even like I've been following that to let you know or tell you a few things about it. It's probably more than I should have, but I'm going to talk about it nonetheless. At the end, maybe give you an idea like what is actually happening and how is the deep history of Europe attached to it. But first, we are going to start with James Webb Space Telescope. So in the last one, we basically talked about why do we need this telescope and its comparison to Hubble telescope, and also we talked about its trajectory, like close to 1 month of journey that it had, the majority part, and where it is right now, where we are going to continue where we left off. Then I want to talk about the propulsion in it after I talk about the telescope itself. And then finally, I guess a good place to give you a good idea would be what is Lagrange point, or what are these Lagrange points, what is L2, why is it over there. To a huge extent, I tried to explain in the last one as well why it is exactly over there, but we are going to do a better job elaborating over here. And combined all these two episodes will give you sufficient idea about what is James Webb Space Telescope all about. We are going to do our best to have fun while we're at it. Science, technology, especially space, it is extremely fun, as it should be, and we are going to have a good time over here. If you're new over here, this is a podcast on space science and technology. We discuss about these cutting edge technologies on a regular basis, now more regular than ever. You can see it 2 weeks consecutively, and I plan on continuing it further. Okay, now we are going to, like I said, continue where we left off from. Now, those who are new, I have full on notes over here, whatever I used to study this whole thing over months in the past, and now I'm going to do my best to summarize things for you guys. So it reached its final destination 29 days after its launch, if I'm not wrong, close to 23rd or 24th of January, now depending on which part of the world you are at. Now right now it is cooling down. Now James Webb Space Telescope, much like Russia-Ukraine crisis, I kept on going through a lot of content, and a lot of NASA scientists have done a great job coming out in public trying to explain a lot of things. Now a specific question came to one of the engineers, and the question was that why is it cooling down and why is it taking so much time for it to cool down. And currently it is not at the final destination, or T2 you can say, the final temperature. The final temperature, some of you guys might be knowing, is 40 Kelvin or minus 233 degrees centigrade. So it has to reach over there. There are different temperatures in the telescope itself, about which we are going to talk later. The infrared camera itself is at 7 Kelvin, which is just 7 degrees of temperature above the absolute zero. Now, if you do not know what happens at absolute zero, no atom can exist at that temperature. At zero temperature, the pressure is zero. Basically, the atoms and the molecules will start stop to move. It will cease to move. That means the electrons will not revolve around its nucleus. The matter ceases to exist. So it is literally impossible to attain 0 Kelvin. And this part, the infrared part of this telescope, which is actually going to do the majority of the work, which is why it is much better than the Hubble Space Telescope, is at 7 Kelvin, just to give you an idea. So overall, that temperature of 7 Kelvin is actually attained using a refrigerant system, cryo cooler, and we are going to maybe emphasize later. But the whole telescope in general, or the majority part of it, somewhere around 24 meters square of area, has to attain a temperature of 40 Kelvin. Now it will slowly cool down, right? And when this question was asked, like, why is it taking so long for it to cool down? Isn't space like a very low temperature? And it is going to take 98 days to cool down. That is 3 months. Now, if you do not know, if you are an astronaut in space, okay, let's say this is you. Better would be this one, because this is actually an astronaut. So if you are this astronaut in space, all right, just revolving around any celestial body, no atmosphere at all. Right now, you sitting on the surface of Earth, you are cushioned by an atmosphere which helps moderation of temperature. The nights are not super cold and the days are not super hot. Otherwise, in the daytime, if there is no atmosphere, you'll be scorched to death. In nighttime, you'll freeze to death. All right. So atmosphere prevents instantaneous escape of heat and instantaneous rise of temperature. So it's like a cushion. Think of it like a flywheel. For those who are from engineering background will understand. So if you are having a very heavy wheel rotating continuously, or even if you have just studied physics, a very heavy wheel rotating, so it will take some time for it to retard its angular velocity, right? Even if you put some external force, because that's the inertia that it has. A revolving body will try to continue on revolving if it is initially revolving. It is kind of the Newton's first law applied in rotary motions, right? Okay, so flywheel does that when let us say a flywheel attached to an internal combustion engine. When there's a combustion stroke, all of a sudden the flywheel's velocity will increase because that's where the power is generated. And then in the other strokes, other 3 strokes, there's no power generated. So if there is no flywheel, we would have a fluctuation of speed, like your car will like that. It will all of a sudden go very fast and then it will slow down, right? So in a similar manner, atmosphere acts like a flywheel for you so that the temperatures do not fluctuate a lot. Now, this astronaut in the space does not have an atmosphere. So what will happen, let us say sun is in this direction, then the radiation heat will hit this astronaut on this side. So its temperature on this side will increase. This is the radiation heat exchange. It is going to be in between the bodies, right? And the other side, on the other hand, will not have any temperature change, or it will be at the temperature of space. So this astronaut right now, if it is not wearing this suit, is going to have one side freezing and the other side burning out, right? So in a similar manner, your James Webb Space Telescope is like an astronaut without an atmosphere. And that is why we are going to need a sun shield. Now, for you to get an idea, the 2 sides of JWST are at following temperature. One side facing the sun is going to be at 83 degrees centigrade. And the other side is going to be at minus 233 degrees centigrade. Just for you guys to understand, I've converted it in terms of degree centigrade. Obviously, you can convert it in terms of Kelvin. I'm not competent enough to convert it in terms of Fahrenheit because I'm Indian. All right. Okay. Just hold on. Yeah. 1 second. I'm going to continue. All right. Sorry about that. But then again, not so sorry, because this is like a conversation. A 1 hour long podcast cannot go without interruptions. If it is going, it is very artificial. So this is how life goes, right? Okay. Now coming back to the point, what I was trying to explain over here. So James Webb Space Telescope is going to have a huge fluctuation in temperatures itself. For that we use Sun Shield. Sun Shield is going to do its best to act like an insulator, and it is itself divided into different layers. Each layer is going to drop the temperature, and subsequently the temperature is going to be dropped from 83 degrees centigrade to minus 233 degrees centigrade. Okay, now it is not that big of a deal to have such a low temperature on the other side. You just have to stop the radiation to come in that side, right? And for people who do not know much about radiation, see, I have taught courses on heat transfer, and in heat transfer for mechanical engineers, applicable for chemical engineers as well. Now in that there's a topic called radiation. So there are basically three modes of heat transfer: conduction, convection, and radiation. A simplest example would be heat transfer from this part of the mic to this part of the mic is going to be obviously through conduction. All right. Most people say that conduction is because of vibration of molecules. That's partially correct. Actually, only 20% of the heat transfer is because of molecular vibration. In conduction, 80% of the heat transfer is because of electron transfer. And that is why you see materials which are good electrical conductors are also good thermal conductors, because it has a lot of free electrons. That is one way of heat transfer. The second way of heat transfer would be convection. Convection would be like, let us say this is coffee and I'm putting a fire down below. So the whole coffee starts to move because of density difference. Higher temperature at the bottom, which is now attained, is also going to be lower in density. And because of low density, it wants to go on top. I do not know how much you are able to understand. It depends on the level of your education. This is a simple principle of buoyancy. Okay. All right. And the material that went up is now on top, and the cooler material is down below, which is now going to receive heat. So it is a bulk phenomena. The entire fluid moves, and you are going to get uniform temperature over time. Okay. All right. The third mode of heat transfer is radiation. Now, pay attention. The first two mode of heat transfer does require a medium. The third one does not require any medium, and that is the majority of heat transfer that takes place throughout the universe. For example, the heat transfer from sun to the earth, it's through radiation. Now, what governs this radiation? If you ask me what governs conduction, then conduction is governed by Fourier's law, right? And Fourier laws, I'm going to put it over here. It basically says that heat transfer is proportional to temperature gradient, and it is also proportional to the area of cross section in the direction of heat transfer. The convection is governed by Newton's law of cooling, which is also saying something similar, that heat transfer is proportional to surface area of contact and the temperature difference. Now, radiation is governed by Stephen-Boltzmann law, and it says that heat transfer due to radiation is proportional to fourth power of absolute temperature. What is absolute temperature? Temperature in terms of Kelvin. From absolute zero, what is your temperature? That is what governs radiation. Now, the only problem is that when this question was asked to that engineer, probably from NASA, that why is it taking so long to cool down? She said basically is that it is taking time to cool down is because radiation takes time. Radiation heat transfer is a slow mode of heat exchange, which does not make complete sense to me. Maybe it is partially correct, but as you can see, fourth power of temperature is the fastest. For example, if these two phones are at temperature 30 degrees centigrade and 60 degrees centigrade, right? So according to the Newton's law of cooling, that is convection, the heat transfer would be something multiplied by 30, because Newton's law of cooling says that heat transfer rate is proportional to temperature difference. But when it comes to Stephen-Boltzmann law, if heat transfer takes place due to radiation, that is 30 plus 273, that is in Kelvin. So you are looking at 303 Kelvin. and you're also looking at 333 Kelvin. So 333 to the power 4 minus 303 to the power 4. Do you think it is going to be bigger than 30? I think so, right? So the main reason why it is taking so long to cool down, I don't really know, honestly. But you have to think about what is it exchanging heat with. So if there's another body nearby, then there will be like T1 and T2, right? But if it is space, that is what we do in solving some of the questions. For example, if you want to find out what is the heat radiated from a bulb in a room, and room is considered to be big, then you are going to consider the second body to be at 0 Kelvin, right? You're not going to consider that. Okay. All right. But the point is that it is going to take that much amount of time according to calculation. The actual NASA scientists will be properly able to answer that. I'm not good enough in that. Okay. But I hope that I was able to give you an idea how is heat transfer taking place. And maybe if you have some questions, feel free to put it down in the comment section. Okay. Now, after that, it will take few more months for it to get sanctioned. Even after the proper desirable temperature has been attained, it will be sanctioned somewhere close to June, when it will be able to start doing some science missions. Now, at this point, I would take some time to answer a few of the questions that were put in the community. Okay, so these are the questions related to James Webb Space Telescope, and then there are certain questions related to Russia-Ukraine crisis. So first, we are going to discuss this. How JWST will work to see the universe? Well, to a huge extent, I've explained it in the last class. Now, I do not doubt that this person has not gone through that last podcast, but it is just a camera, right? A camera with huge amount of capabilities. It has infrared detection instrument, and because of that, it will be able to see farther places. It will be able to accommodate the redshift, and because of that, limit increases. Now, I would like to continue answering this question using this next question. How long, no, not this one. How far back in time can this telescope see? So basically, they are saying that you can see the birth of this universe. So we are talking about 13.8 billion years in past, the birth of the universe. That is what they're saying. And we have talked about this before, that even Hubble telescope was able to see a picture that was 13.4 billion years old. So obviously, with such a high capability of JWST, we'll be able to see that. Now, can JWST rotate? Yes, it can. And how long? Now, so I will answer this one. Can JWST rotate? Yes, certainly it can rotate. It can see in all directions depending on where it is, or if we consider the full rotation around the sun, apart from in the direction of sun. It cannot be rotated in the direction of sun, or the sensors cannot be rotated in the direction of sun. Otherwise, obviously, it will get saturated. But the second thing is that the sensors which are made to operate or is designed to operate at 40 Kelvin would be facing a temperature of 80 degrees centigrade, or you can say 353 Kelvin. So that is definitely not possible. So you cannot see Earth, you cannot see Venus, you cannot see Mercury, you definitely cannot see Sun. Apart from that, the rest of the universe is your playground. You can point it in any direction. How long will James Webb Space Telescope last? It will last for 10 years, and we are going to understand why it is limited to only 10 years when we start studying about propulsion, which is my plan. I'm going to cover this. After that, you'll understand exactly why it will last only for 10 years. Okay, further questions that are coming in your brain, please put it down in the comment section. I do not claim to be an expert, but I work hard to find out the answers, that I can assure. Now, the next one is that we are going to start discussing about telescope itself, the JWST. What is it, and what is it really made of? Why are these things over there? Why is it so big? Now, telescope itself is a marvel when it comes to engineering. It's a masterpiece. Now, in general, it starts from the launch vehicle, obviously. Now, once it is launched, launch vehicle's job is over. But the launch technology should be there. It was already there. And mostly the telescope was designed according to it fitting the launch vehicle of ESA, that is Ariane 5. After that, image processing is a very important part of it, because that is what you are there to do. The next is cooling system, because your image processing will not be working that appropriately if your cooling system is not that good, because like I said, infrared sensors should be cool. And the reason is the same. You're trying to look at very distant, dim images. So the photons or the signature that you're getting from that distant object, the signal is very low. So sometimes you are going to get as low as 1 photon per second, which is extremely low. So the farther you want to look, the cooler your telescope should be, and thus cooling system is extremely important. And finally, the sun shield is very important, because like I said, there has to be a difference of temperature maintained, again coming back to the cooling one. The mirror itself, the kind of 3 cameras or reflectors about which we are going to now start to discuss one by one. So I'm going to put the images on the screen. People who are going through the audio version, it would not be that appropriate, and that is why Spacecast does require the video version. So we can start discussing with the sun shield. The sun shield, the main objective of that is to act as an insulator, maintain a temperature difference of close to 300 Kelvin, higher than that, right? So the side facing the sun is going to be at 83 degrees centigrade, right? And then there are layers of insulation. And that is the thing when it comes to radiation insulation. Even if you look at nuclear power plants, and if you look at the shielding, that is the outermost part of any nuclear power plant, that is the dome that you see, that has layers of insulation. And even the thermoses earlier used to have layers of insulation. Why layers are good? Because in general position, if you are sitting on Earth, layers will be having air in between, and air is a tremendous insulator. You know what's worst as an insulator? Vacuum. And that is why new age thermoses have vacuum in between 2 layers. They have like all the air sucked out, and vacuum is going to act as the best insulator that you can have. No other material will be able to do so. Now, why is that? Well, because vacuum will have only one mode of heat transfer, that is radiation. Okay. Now, since there's no material over there, there's no gas, you cannot have conduction, you cannot have convection. Okay. But then again, Ashish, you said that we are having kind of a very fast rate of heat exchange when it comes to radiation. Then on Earth, if I'm having 2 plates and in between there's vacuum, won't I have a faster rate of heat exchange? And I think that this is what that lady wanted to say when she said that heat transfer because of radiation is quite slow. Now, please understand, the radiation heat transfer comes into effect only when the temperature difference between the 2 bodies are extremely high. Does radiation heat transfer takes place on Earth? Yes, it does. Right now, there's a radiation heat transfer taking place between me and the mic as well. But that is very negligible. Right now, is convection heat transfer taking place between me and the mic? Yes, it is, but very negligible. Right now, is conduction taking place? Not yet, but now it is, because now I'm touching the mic. So now I'm touching the mic. What kind of heat transfer is taking place between me and the mic? All 3: conduction, convection, and radiation. But the thing is that temperature difference between me and the mic is very, very low. Got it? And that is why you are not going to face any heat transfer. Maybe a topic that we can cover later. There's another question, that why do you think that this metal seems cooler even if it is at exact same temperature as, let us say, a phone made of plastic over here? That's a completely different topic. It's about what you feel, not exactly about what it is. But in real life, on the surface of Earth, there are few places where radiation heat exchange is dominant. And one example I can give are the furnaces, where the temperatures are seriously high, like thousands of degrees centigrade. Why is that? See, radiation heat exchange really comes into the picture when temperature differences are very high. When temperature differences are high, you'll see that those three formulas that I talked about, radiation really takes over. And maybe where James Webb Space Telescope is, the temperature difference is very low compared to that. And if we look at it, so the temperature gap is kind of, I do not know exactly what temperature it is at right now. Maybe it is at 83 degrees centigrade. But that does not seem that low to me. If you know a better answer, or maybe you know someone else's better explanation, maybe an article, please suggest it down in the comment section. And I'm definitely going to go through it. One thing I really want to point out. See, sometimes when I say light year, I mess it up. Okay, so I think in the last one I said light year is years of time that it takes for light to be from one point to another. Now, honestly, I know what light year is, but sometimes I make mistakes because these are completely unscripted podcasts. Well, terrible timing is the distance that it travels in 1 year, obviously at the speed of light. Like I said, it's terrible timing. So food is going to be cooked. I'll have to take a break of maybe half an hour or so, and I'll continue where we left off. All right, sorry about that. No, not so sorry about that. We are back over here. And we are going to continue with what is this telescope made up of. We are going to discuss in detail. So as I was saying that there are various layers. So one by one we are going to unwrap these layers so that you understand what exactly they are made of. So if you look at the camera part, okay, so there's one gigantic mirror that I know that all of you guys have seen. It is made up of 18 different hexagonal plates. It is coated with gold, and it is coated with 0.1 micrometer of gold. Gold is very malleable. It can be stressed very thin. It's not a new technology. And obviously you want the reflective part. You want to avoid the weight part. Just below the gold, however, is something very interesting. These plates are made of beryllium. Now, why is it made of beryllium? Because it is a very light metal and it has a very high what we call Young's modulus. Young's modulus of beryllium is 300 gigapascal. And if you look at what Young's modulus actually is, there comes a little bit of mechanical engineering. Hooke's law says that stress is directly proportional to strain in the elastic limit. And Young's modulus E is the slope of that straight line within the elastic limit. So according to Hooke's law, till the elastic limit, stress strain curve will be a straight line. And if you look at it graphically, that slope is Young's modulus, that is stress by strain. So if stress by strain is very high, that means that you need a large amount of stress to cause any amount of strain. In simpler terms, stress is amount of load that you apply. It is proportional to it. Stress is actually the internal resistive force per unit area generated within the body. But obviously, it is proportional to the external force or load that is applied. Obviously, it is also inversely proportional to area of cross section. But you get the point. So, a high amount of stress is required to be generated within a body to create a very tiny amount of strain. Strain basically is change of length. If you look at the formula, strain's formula is change in length divided by original length. So in proportionality with the original length, how much is the change in length, or basically you can understand the deformation. So if Young's modulus is very high, the material is difficult to be deformed. So you are going to have a stable geometry of these mirrors. So there are 18 of these. All are beryllium plates and all are coated with 0.1 micrometer of gold. Why gold specifically? Now, obviously, gold is a good reflector, but better reflectors are there. For example, what you have in silver, right? But gold is a great reflector in infrared region. So if you look at the graph, which I'm going to put right now on the screen, then you'll see that a huge amount of stability is present when it comes to gold, when it comes to infrared region. And that's what we are looking for, and that is why we have selected gold. All right, so beryllium being lighter than silica glass, what you use in other mirrors, are still not reflective, and so you are going to require a reflective coating. So this is the first reflector. This is where the light is going to fall the first, which is in the direction opposite to the sun, protected by the sun shield, should be at a temperature of 40 Kelvin. And this is the big bucket you can think, which is going to collect all the raindrop, or in other terms, is going to collect all the photons from the distant parts of the universe. These are going to be first collected by this gigantic mirror made of 18 hexagonal beryllium plates coated with gold, and is going to be redirected towards the secondary mirror, which is sitting at the focal point of this first concave kind of mirror. Now, because it is divided in a lot of parts, it is possible to adjust the focal length depending on what you're trying to look at. And one thing I forgot to mention, why it is hexagon. Obviously, other alternative options would be triangle. Now, if you look at trusses, bridges will be having triangular portions. Have you seen at any frame? For example, in mechanical engineering, we have this one thing in automobile engineering, especially when it comes to Baja competitions. We call it roll cage. So majority of the part of roll cage will be triangular. 3 rods in triangular fashion. They will be welded because triangles are the strongest. But that is a different deal. It is what we can say, trusses are a different topic. A triangle definitely would be stronger, but also these are nastier because they are having pointed edges. So the largest angle that you can expect out of triangle, a genuine triangle, would be close to 90 degrees. Obviously there are obtuse triangles as well, but then again its area of cross section becomes smaller and smaller, and you're looking at a flat piece of material. But hexagons, it is possible to go for a larger angle, and ultimately they settle down. Obviously nobody knows exactly, other than the NASA scientists, what were the actual conclusion or calculations, but I can do my best to explain it in terms of simple science and engineering. So this is the first layer in terms of you looking from the side of the camera. Okay, now let us do this one thing for you guys to understand properly. We are going to consider that the sun shield is on left and the sun is on the leftmost part, and the camera is on the rightmost part. So from now on, when I say left and right, this is what I mean. Obviously in space there's no left and right, but this is how our conventions are going to go. So if you start from the left part, now this one is going to face the highest amount of temperature, and that is 83 degrees centigrade. So it has to be super strong. Now I know that you must have heard of the material Kapton, and there are in total 5 different layers. All of them are coated with Kapton. Kapton is transparent, but then again it again has an aluminum coating for it to not be transparent, because if it is transparent, obviously there are 3 things in radiation I'm going to explain quickly. Number 1, reflectivity, transmissivity, number 2, and absorptivity. If a material is transparent, then we are having a high transmissivity. Now all of these 3 are basically fraction of your radiation that is going to, let us say, pass per the total amount of radiation that is falling. So if you're talking about absorptivity, it says that fraction of radiation that is absorbed with respect to the total radiation that fell on that, right? So if transmissivity is very high, then obviously a lot of radiation is going to pass through, so it has to be made opaque. All right, so the first layer, all the 5 layers are having similar Kapton fashion, but the first layer is a little bit extra special. Now, what is that? It is having an extra silicon coating, which is of 0.05 millimeter or 50 nanometer. Now, why is this silicon coating there? Obviously, there's no doubt that the first layer is going to be facing the bloodiest time over there to hold the heat. And silicon, what it does over here is that it increases, it has high emissivity, and in most of the explanations when you look at it, they're just going to say that because it is having high emissivity, it absorbs most of the heat that is falling on it rather than letting it pass away to the next layers. But what is really coming into play over here is something that we have studied in heat transfer, and is called Kirchhoff's law. Now, according to Kirchhoff's law, for thermal equilibrium, once the equilibrium has been attained, emissivity is equal to absorptivity. Now, what is emissivity? I'll try not to make it a very theoretical podcast over here, but absorptivity is, like I said, the fraction that is absorbed, right? And whatever is absorbed is not going to pass through, because emissivity plus absorptivity plus transmissivity is always equal to 1. So increase of one, let us say absorptivity, is definitely going to cause decrease of the other. Okay, but that is the reason they are saying that since silicon has high emissivity, it is going to absorb majority of the heat that is going to fall onto it, because according to Kirchhoff's law, emissivity is equal to absorptivity. There are a lot of conditions and assumptions, but obviously to simplify, we say things in this manner. All right, then the next 4 layers that we are having, they are going to be of thickness of 0.025 millimeters. So that's pretty thin. But I know a lot of people have been comparing it to the thickness of hair and all, but to be honest, this is not a new technology. We have been making a lot of thin coatings for a long time. So this is not something extremely new, but I just wanted to let you know. Now, each layer is designed in a way that the radiation is going to bounce off of 2 surfaces, the space in between 2 surfaces, the radiation is going to bounce off, and ultimately, according to the design, it is going to bounce away from your infrared sensors. If it goes towards, that might be a problem. So the whole design is obviously extremely complicated, but this is how the sun shield is made. And right on the rightmost part, beyond the fifth shield, we are having the infrared detection instrument, which has its own cryocooler to maintain it at a temperature of 7 Kelvin. Now, it receives its photons or electromagnetic waves through the secondary mirror, which is receiving its electromagnetic waves from the 18 hexagonal mirror array that we talked about. So it is going to be falling one, then to the second, and to the final infrared sensor, which is going to read the data. Now, infrared sensor itself is a very complicated instrument. Now, it is having one of the, definitely the best, what do you actually call it in terms of camera? We use it a lot of times when we are trying to buy a camera, for example, a camera through which you are seeing me. So few lenses have the capability to adjust shakes or to nullify shakes. So when a camera is shaking, you see that blurry one, right? Blurry image, but that is not going to happen if it has that shake adjustment mechanism. I'm going to put the name over here if it comes to me later, but basically you are not going to get blurry images because of this, and that is a very next level thing. Let me know if you want me to discuss that and the cryocooler in detail, because those are very, very complicated topics, and to a huge extent beyond the scope of today's podcast. Okay, but I can surely do the research and let you know. Another thing that I wanted to explain, that I know for sure that I'm not going to be explaining properly without a board and a marker, is the crazy orbit of the James Webb Space Telescope. like what is actually going on. So it is like a roller coaster, up and down, different kinds. So if you make it stationary, if you make the rotation of James Webb Space Telescope around the sun stationary, or you look through from a reference plane which is rotating at the same velocity that Earth is revolving around the sun, that means that now in that way of looking at it, or in that reference frame, JWST is static, then it is orbiting nothing. So it is not just orbiting the sun along with the Earth, but it is orbiting the sun along with Earth and orbiting nothing in a plane parallel to a plane that would go from North Pole to South Pole. Obviously, Earth is also tilted in itself, its axis of rotation. I guess that you got the point. Okay, so that is something that I would only be able to explain with a marker and a whiteboard. So do let me know if you want me to explain, and do let me know if it is getting too heavy, because I want it to be fun, not so heavy after all. All right, okay, any questions and any suggestions goes down in the comment section, and all of them will be addressed. And also do let me know if you're finding it extremely easy, because if it is a live session and you are listening to me continuously and I'm getting the feedback, or I'm able to see your faces, it would be easy to understand whether you are able to understand or not. Your way of feedback would be putting in the comment, and doing such good things also helps us to promote this podcast, which is also very necessary. We are all, you and me, sir, we are both aware of the garbage content produced on YouTube every second, and good content is not promoted that well because people are not dancing over here. Now, not saying that I'm really looking for that crowd which is going to be impressed by dancing, but still I am firmly standing with the idea that there's an abundance of intellectual people in this world as well that really wants to learn through these social media platforms, and those are the ones that I'm going to target. Now, next I wanted to discuss propulsion, but for it getting extended long enough, both you and me will find it better to go for some other topic. Now, propulsion and Lagrange point, I can discuss it later. In the next podcast, we are going to discuss it, and there itself, we can understand why is James Webb Space Telescope is only going to last for 10 years. And in short, if I say, the main reason is the limitation of fuel that it carries. So it carries hydrazine, a fuel that is given by the chemical formula N2H4, and it is carrying 191 liters of it. So obviously over some time it is going to run out. The biggest problem with JWST is that you cannot resupply, but also NASA side by side is working towards if we can resupply in the future. Nobody knows the technology that we are going to achieve in 10 years. Maybe it is going to be mind-boggling and completely different, or maybe it will be nothing. Because like I've said before as well, 1960s we were landing on moon, and this is 2022, and kind of Elon Musk said it best. If you look at the history of space science, it's kind of converging. It may be the only technology or an only branch of science which is reducing. But then again, I'm seeing the Artemis project taking place properly. Elon Musk project of landing on Mars itself, the Starship itself, is working at a tremendous pace. And on top of that, again, kind of a cold war starting in between United States and Russia might just boost space technology. Maybe the only good thing that is going to come out of this war. Now, since I've already spoken of it, let us talk about it, and we are going to continue JWST in the next one. Now, related to this topic, what is going on in Russia and Ukraine, definitely people should talk about it. Now, we had seen the problem of Afghanistan before. Okay, Afghanistan was never a peaceful place, and when US troops left Afghanistan quite recently, we saw massacres, we saw people trying to jump on plane. Literally, they would hang over the wings of the plane if they could to escape that place. We have seen the footage. It's terrible. It's kind of sad. And that happened. It's terrible. I think it's almost a year now. We have seen the Israel-Palestine crisis as well. Rocket launches working and people dying. And places getting bombed, civilizations getting bombed. There's nothing worse than that. But this one just might top it all. The Russia-Ukraine crisis. Now, I do not know how long you've been following me, or if you even follow Talk and Fire podcast, but around a year ago, me and Komal talked about the Russia-Ukraine problem of what happened in 2014, because we were seeing tensions last year as well. You'll have to look way back, at least till 2014, where Russia annexed Crimea, and that's the beginning of all the problems. Not only the Crimea part. Now I'm going to be showing the maps on the screen. Actually, maps are in my head, but it might not be for you, so you might take a look at screen every now and then to understand what I'm referring to. So Russia annexed the Crimea part, which is the southernmost part of Ukraine. It is strategically very important, and after the current government at that time, that is Viktor Yanukovych's government, was overthrown by a revolution because he was anti-NATO. He was removed. Russia gave him the asylum, and new pro-NATO party was established over there, and Russia did not like it, not one bit. And so he took over Crimea, which is also not as simple as you think. It's not a bombardment and running over a country and slaughtering people and just taking it over. It took it very, very step by step. All right, so Crimea first declared itself independent, and then Russia took it over. In a very similar manner, in the same year 2014, the Donbas region, that is Luhansk and Donetsk, which is the easternmost part of Ukraine, started to be led by separatists. Separatists basically meaning that they want to walk away from Ukraine. They are pro-Russian. And in general, if you look at the demographic of Ukraine, it is super twisted. Kind of very similar to what you saw in Israel-Palestine. When there are different ethnic people or different languages, there's almost always a problem. So if you look at Ukraine's map, and I'm going to use few of the maps used by a professor who gave a speech at Chicago University, and the lecture's name is "Why is Ukraine the Fault of West?" All right, and I just searched him so that I can give the name of him. John Messemer, probably. I cannot pronounce it properly, or maybe I did perfectly. Okay, so I'm going to use his maps because I found his maps to be the simplest and the easiest to understand. Okay, so Ukraine is terribly divided amongst the people who speak Russian and the people who speak the Ukrainian language. The East naturally are pro-Russian, and the West naturally are pro-NATO or pro-West. And because of these divisions, a lot of time voting took place that you want to join the NATO side or you don't want to join. And naturally, the East voted against joining NATO, the West voted towards. And even in 2014 election, the Donbas region people did not get to vote. Now, why is that? Because they were fighting a war against the Ukrainians there itself. Now, some people do not know the Donbas region, only 1/3 of that part was actually controlled by the separatists. The rest was still in the control of Ukrainians, all right, the Ukrainian government at that point. Now, what has recently unfolded, and it is unfolding so fast, that in the last Spacecast, which was not a week ago, I was just saying that we are at a brink of war, and now it has actually happened. And today, the date in which it is getting recorded is 26th of February, and it probably will be published in a day or two. So I don't even know how much things will change by then. Okay, so the first step was to amass military. So initially, Russia just sent troops, 110,000 men in the border of Russia-Ukraine. And nobody just does it for fun. They do it maybe to show the threat that the other country is in. Or maybe they do it because they actually want to invade. Now, people are so optimistic. Naturally, people are very optimistic. The last thing that they want to believe is that it can happen to them as well, and the war is just going to happen. Okay, so Russia said that we have no intention of invading Ukraine. Some people believed it, some people did not. One set of people which was very adamant in not trusting them was United States. Joe Biden was saying it from the beginning itself, that they are going to invade. They're going to go for a full-scale invasion. They're going to go for Kiev. Kiev is the capital of Ukraine. So now that makes a lot of sense, because there's no doubt that there would be a lot of American spies in Russia, and there would be a lot of Russian spies in America, and they are going to get the intel in the best manner possible. Okay. Now, there's a problem over here. Some people might be wondering, why isn't the West sending their armies in Ukraine? Well, that's because Ukraine is not a part of NATO. That is North Atlantic Treaty Organization, probably. Okay, so in 2 minutes or so, it will be definitely, because I'm going to read it off the internet. Okay, so it is not a member of NATO, so they cannot send troops in, and that is why you were seeing a lot of weapons sent by the West, so that Ukrainian armies will be able to defend themselves. NATO full form, it stands for North Atlantic Treaty Organization. Probably what I said. I tend to forget what I said. Okay, so now what the situation is that, first of all, the second move was that Russia started sending their troops even in Belarus. Now, this is a problem because Belarus is right above Kiev. Now, if you encircle a country from 3 directions, it is going to be a problem. Like I said, in 2014 itself, Crimea was taken. So the south is taken. Now, like I said, it is a very strategic spot. It's probably the best spot for you to have amphibious landing on the southern coast of Ukraine, which is Odessa. So what is amphibious landing? Well, you land from the seas onto the land. A great example for that would be D-Day. Another few examples are Japanese landings when Americans went from island to island, for example, Okinawa. And then what was that? Great. Best time to forget what I was trying to say. What was that victory in Pacific Day? Which island was that? The last final island. Oh God, the worst time to forget it. But forget about it. Other few landings would be landing in the southern coast of Italy, and there are a lot of examples. So that is what they finally did. Now you basically have one of the world's biggest army encircling your country. Nobody does this just for threats, because this is very costly as well. So now you have north, the east, and the south. More than sufficient for you to do whatever you want to do, especially to a country which is not having nuclear weapons. Now, there's a funny thing, I do not know if you know it or not. Ukraine could have been one of the biggest nuclear powers in this world today. A lot of you guys have watched that TV series Chernobyl. Chernobyl is geographically in Ukraine itself. It is north of Kiev and is already taken over by the Russians. Now, Ukraine itself has a space program as well, and the reason for all of this is because Ukraine was a part of USSR till 1991, until the USSR disintegrated. So it's the same country, and it is very close to Moscow. So it's a part of USSR. So obviously the technology or the education, it all will develop simultaneously. Matter of fact, Ukraine had to dismantle a lot of its nuclear weapon when it separated from USSR. And this was the denuclearization of Ukraine suggested by Russia itself, while saying that if you denuclearize your entire country, we are going to protect you. Now, right now, we are saying it's kind of the opposite happening. Now, what is Putin saying? Like, why is it invading? Obviously, you have to justify a war. This is not 1940 where you can see, I hate all the Jews, I'm going to kill them all, and we need more land because German population is 85 million and we want more space. Okay, not going to work anymore. It is 21st century. Anything that you do is visible to billions of people. So, according to Putin, his statement is that there's genocide going on right now in Ukraine, in Western Ukraine, and there are concentration camps, and it is against the genocide is against the ethnic Russians. So we are going in to protect them, because the government currently that we are having, that is the President Zelensky, it is very corrupt. And another argument is that he is the president right now because the Donbas region did not get to vote. This is their statement. This is their narrative, and that is the whole propaganda within Russia right now. And if you look at it, Facebook is nullified over there. It is highly selective. I do not know if they have banned or not. Just a few minutes before I started recording, a friend of mine said that they have banned. I'm not sure, but it is obviously highly censored. And in other regions also, for example, YouTube and all, I'm very sure that it would be censored. They just shut down the office of DW News, which is a German news channel in Russia. They had to just shut it down and return back to Germany. So this is the situation that the Europe is right now. And I'm terrified, man. Seriously. A lot of people, especially in India, because we are so far away, might not pay attention towards it. And especially even in America, a lot of people are not paying attention towards. You do not see it. You do not see like people like Joe Rogan and all talking about it that seriously. Okay. I do not know what's up with Joe Rogan, because nowadays the only thing he talks about is vaccination. That's it. Either for or against something. That's the only thing that he wants to talk about. But this is really a big deal. It's a big deal, because we are seeing a full-scale invasion by a superpower, which is a nuclear power, on a country which is its neighboring. And we are seeing intentions of Putin trying to bring the USSR back. And that, if that's not threatening to you, if Stalin was not threatening to you, I do not know what is. Because the whole communist regime that ended in 1991, it was definitely scary, man. There were, in 1960s, the Berlin Wall problem, or we were at the brink of a nuclear war as well. That I still remember the person, that Russian who seized, that was the third person whose authorization was required to deploy a nuclear weapon. Let me see if I remember or not. What was Vasily? Vasily something. Like I said, I cannot remember it when I have to. But if not for that person, there would be a nuclear war that has already started. And then the Berlin Wall was created. Germany was torn into two. And it was so complicated at that time that, yes, there's East Germany and West Germany, right? But there's East Berlin and West Berlin. So Berlin comes in eastern part of Germany, and it itself is divided into two parts. So you're looking like a country within another country. And at one point, there was a ban of transport of goods as well, and they cannot go through road. So they started to fly the goods into the western part of Berlin. So is the situation as tough as we saw during the Cold Wars? No, not yet, because we have seen this before as well. There were a lot of rebellions in the Eastern Bloc For example, at that time, Eastern Bloc comprised of what we see today as Poland, Czechoslovakia, uh, Estonia, Latvia, Lithuania, Belarus, obviously, and Ukraine. And I think Hungary is also in that. I'm going to put the map over here. So there were rebellions almost in every country, and they were all suppressed. It was only when Gorbachev came into power in 1985 that he really wanted people to be happy, which was something new for the Soviet Empire. And what he said is that, see, you can choose the future for your people. And then again, there was revolutions, but the only thing that USSR did at that point was nothing, and they let it happen. And automatically, one by one, all of these countries claimed freedom. And that was the disintegration of USSR. So in that time also, until they decided not to do anything over there, it was pretty brutal. Every time it was suppressed. In 2008, a similar thing happened in Georgia, that is in the south part, in the southern part of Russia. Georgia, not I'm talking about that one state in United States, but a country. So similar things have happened before as well. Annexation of Crimea also was very threatening, and there was huge amount of sanctions imparted on Russia in 2014 itself. And now I think that you must have gone through the news. If you have gone through the news, a lot of sanctions has taken place that we are basically not going to do trade with you. You want to attack an innocent country, please go ahead, but we are not going to talk to you. Kind of like that. Okay. Now that there's a problem that which side is India going to take, because India is having strong military ties with Russia, we all know, and also it has very good ties with United States. But it is not as simple as going for or against. Why are you willing to go to a war which you can avoid? Everyone wants to avoid war. Now, in a completely different context, I'm going to talk about few things which is not related to what is going on currently. Everyone wants to avoid war, because of which war happens. Maybe. Now, let me explain a little bit. So, when Hitler was in power, the main pivotal point was 1939, and he wanted to take the Czechoslovakia part, which was ethnic German. And he said that I'm going to take it. And then everyone was brought to the meeting. At that time, the Prime Minister of Britain, that is Neville Chamberlain, went to Germany to have talks. Prime Minister of France went over there as well. The only person who was not called was the leader from Czechoslovakia itself. They decided the fate of Czechoslovakia. Now, how did they decide? Well, they decided whether Hitler, if you're going to invade that part of Czechoslovakia, are we going to declare war on you or not? And the decision of that meeting was that no, we are not going to declare war on you as long as you only take the ethnic German part of Czechoslovakia. Czechoslovakia, if you do not know, is right next to Germany, on the eastern side of Germany. Okay. So they said that, okay, we are not going to do anything. And that was a big problem, because that increased the hunger of that lustful man. He now believed that, okay, West is really afraid of war. So what if I do more? So, like I said earlier, he said that he's only going to take the ethnic part of Czechoslovakia, and few days later he went out to conquer the entire Czechoslovakia. He went out and talked to Stalin and built a pact, a peace treaty, that if I'm going to invade Poland, you are not going to declare war on me. Matter of fact, I'm going to take half of Poland and you are going to take the rest of it. That was the pact in between Hitler and Stalin, the Molotov-Ribbentrop Pact. Okay. And there they went. Hitler took half of Poland as well. And now they just had to declare war. So France declared war and UK declared war on Hitler. But pay attention, United States is still not in war yet. See, that is the thing. You can say that you are playing neutral. If you don't stand with me now, they are going to come for you as well, which is completely true. But every country looks for their own safety first. That just might be the reason for gigantic wars to happen. So they declared war on Germany directly, and next thing you know is that Germany is invading Belgium. It is going for France. There's a small country called Luxembourg, went through it, brushed through. France fell within weeks, which was really a tragedy for them. They were just not ready. They were standing on the border of France, and there was some intelligence as well. Back then, France still worked on the same intelligence that people are going to hand over letters to another people just by traveling through motorcycle or cycle. They thought that if we are going to go for radio, it can be intercepted and we can be hacked. Well, did not played out that well for you anyways. So the transportation is too slow anyway, and when they heard that Germany is amassing their troops on the French border, they just said that that's not possible. Well, that is what I'm talking about. People are always optimistic, but sometimes you have to think about the worst case scenario, because that's our natural way of living, that we want to shut our eyes that something so terrible can happen. And that led to the fall of an entire democratic country. Now over here, I want to really emphasize, I know a lot of people in this world complain about so much expenditure going on military, when that much amount of money can go in health benefits, in feeding the starving people, in education. There are a lot more noble things to do in this world than war. War probably would be the last one in your list when it comes to noble things. But at the same time, you are forgetting that self-defense or defense itself is the very pillar, the most important pillar of democracy. Why? See, your democracy is very beautiful as long as someone outside does not barge in to take it. I do not even know barge is a word or not. Maybe I just made it. Purge in to take your freedoms, take your rights. So a huge important part of democracy is whether you will be able to defend your way of life or not. And that is why defense has to be strong. You have to be that strong stick if you want to stand firm when everyone else is trying to bend you. And that is the problem that we are seeing right now. Everyone was against India as well when India was trying to build its nuclear weapons. But India knew at that time that looking at the neighbors that we had, well, we have to protect ourselves. Now, everyone will say that don't do this, don't do that, but they are not going to be over there when some other country is attacking you for front. For example, that is the argument of why aren't the West sending, or NATO troops are not being sent to Ukraine right now. Because what we are seeing is a clear-cut invasion, right? But they are going to say that Ukraine is not on paper a member of NATO. So some people are going to say that, see, it is your moral obligation to help that country. But you also have to understand that this geopolitics does not work on your moral values or your emotions. You have to understand that, see, you come today, you're going to die in, let us say, 100 years. When someone else is going to, if you start looking at the emotions of people, it is never fixed. And if you are going to send your troops, that means a clear-cut war between two superpowers. And that is huge. And that's probably the next thing that I'm going to discuss, because I've gotten a few questions over here. And one of those is that what if World War III happens? Is it going to wipe out the entire civilization? Well, we are going to discuss that. So I'm never going to pretend that I know the answers, and that would be the funniest thing that I've said today, that I know all the answers. Nobody knows all the answers. I think that even 60-70-year-old world leaders do not know the answer. We humans are so complicated. For example, just look at Europe. If you look at Europe, it's the pedigree of disaster. Always something or the worse has happened over there because it is designed like that. First of all, you look at the west of Europe, and there's United States, Canada, Mexico, and you have on the east Russia, you have on the south Australia, you also have a connection with Asia. It is the crossroad of the world. And on top of that, to make it worse, it's super flat out. What do I mean by that? If you look at the Eurasian plains, it's super flat. Now, why is that a problem? Flat fields are pretty fertile. It is easy for transportation. Why is that a problem? It is easy for transportation because now the tanks are going to roll. And that is why Europe is so unstable, because it is almost impossible to defend a border which is in the middle of Eurasian plains. Now, you might be thinking, oh, why is that? I'm just going to create a barricade. I'm going to send tanks over there. Well, okay, humans are small. We are not that big that all of us are going to create a chain and stand on the border. So there are a lot of vulnerable points. So the enemy, all the enemy has to do is create a two-prong attack. And from two different sides, it is going to encircle you. This is exactly what happened in 1942 when Operation Barbarossa took place. And they were just encircling. Number one encirclement took place in Minsk, then down below in Kiev. And one by one, the city started to fall. And thousands of people just captured, killed, joined the prisoner of war camp, things like that. So it is. Now, I'm not saying that one country which goes out there and conquers it is very stable as well, because the next country is going to do the same thing. Again, the war is going to continue. So if you look at just the geography and start looking at how complicated it is, there's no wonder that very few people might be knowing the answer. Maybe nobody knows the answer to how are we going to stay peaceful with such a pedigree of disaster. And on top of that, if you look at, humans are too smart and too dumb at the same time. For example, we are smart enough to establish communication throughout the world. Throughout the world, the entire world is connected. Right now, you know what is the news maybe at New York, or you know what is going on in Ukraine. But at the same time, we are so dumb that if a person speaks a different language, hey, how's the day? What are you doing? And you're, wait, what's that different accent? I don't like it because you do not speak like me. I do not know what is your problem. I just speak different. We speak the same language. But there's a problem. Hey, you look different from me. Your skin color, why is it different? Hey, dude, we are having 2 hands, 2 legs, 2 eyes, everything's same when it comes to anatomy. The only difference is my skin color, and that's because I've lived in a tropical place. So what's the problem? I do not know. Maybe I do not like you because I have not seen people like you before. So there's this problem that we are too dumb simultaneously. And it's not like human collectively is an animal, or human collectively is a person. You can't even look at it. Some of us are smart and some of us are super dumb. That's a problem. So if a smart scientist develops a cell phone, a dumb human is also going to use it. That's the problem. It's all a recipe for disaster. That's the problem. That is the reason why we have seen so much war in this world. The only generation that saw less war were kind of from the 60s to the 2015 or 2019, close to that. After that, we have seen so much crisis, and small wars have always happened. The India-Pakistan problem. For example, if you start from World War II, right after that we have Korean wars, we have Vietnam War. The Cold War is continuously ongoing. There's always some problem or the other. There's the Checkpoint Charlie problem, the Cuban Missile Crisis. Then if in India you look at it, Indochina War, India-Pakistan War, 1970s, 1960s, we are always 1999 Kargil War. There's always something or the other going on. It's almost like peace is a problem. or war is interested in you. There's a great quote that is said by a very wise man. I do not know the name of, or maybe someone in the YouTube comment section said that you might not be interested in war, but the war is interested in you. That is how we have been, and I cease to accept that we humans are so small that we can't live without that. But then there are people who just every now and then come into power who just believes that taking over a land for force is going to come up with something good at the end. It never happens. Look at any tyrant, look at any dictator. They all went for conquest. Why did they all went for conquest? They all went for conquest because a dictator has to keep in chain thousands and sometimes millions and sometimes billions of people. They are going to have surveillance on that. They are going to make sure if someone is against the government. They are going to make sure if there is some uprising against the government. They have to monitor that. Is that free of cost? No, somebody is going to do that for you. So you'll have to pay that person. So it is super costly. You have to run propagandas. Maybe you will be slaughtering a certain class of people, and then you will be saying that, no, we're not really doing that. But you hate because you're freaking racist, man. So these dictators, they're a problem. So obviously you'll be running propaganda machines. No, we are not really doing that. It's just that people are saying different things and there are some haters and they do not want the progress of this nation. So we are just going to run the propaganda machine, feed them with bullshit information. So it's not free of cost. People are working to create that propaganda. You're telecasting that propaganda. It costs money. So sooner or later, dictators are always going to run out of money. And when they do, they try to find money somewhere else. And that is the neighboring countries. That is the simple thing that we have seen happen for so long. And as long as dictators are there, or there's no democracy, a proper democracy in a country or in all the countries, there's a problem. Until that point, we need army. We need military forces to defend our democracy. But here's what I want to end it with. I started to realize that it went completely in different direction. I don't even remember where I came here from, and I don't even know how long I've been talking about this, but I hope that you have liked it. Ultimately, democracy will win. This is what I believe. It is a machine that is going to continue on expanding. You know why? Because democracy itself stands for demo, that means people, run by the people. That is the problem of dictators. One person cannot manage or control thousands and billions of people. Rather, you have to leave it to the freedom of people. Let them decide how they want to live. And give them the freedom, give them the choice, let them live the way that they want to live. That is the only way for you to have progress. Otherwise, all your resources are going to continue on going and controlling those people. And there's going to be no creativity because those people are not free. The first day I entered Bhabha Atomic Research Center, I still remember there was a gigantic poster of Dr. Homi Bhabha. And down below, there was a quote that said, scientists are to be left free. A person who is not free is never going to be creative. That person is chained. So that person is going to live its entire life thinking about how I escape this chain. Free and safe people will be creative, and they are going to increase the standard of living, or they are going to take the humanity to the next step. And that is why ultimately people are going to be free. There might be a lot of bloodshed. There might be a lot of people who would have to suffer. There would be wars. A huge percent of population might die because at the end, when these dictators are pushed to the corner, they are going to do anything to survive. Look at Hitler, what he did in his final hours. He said that every man child alive will be defending the country. He said that right now Germans are dying. It is the fault of German people. What the hell? How is it fault of them? You started this war. You are so oblivious that you can't even accept the fact that this is your fault. You know what he said before he died? At least we fought the Jews without trying to hide it to anyone. We fought them head on. This is the kind of mentality. A dictator will burn its own land just to rule over the ashes. So when a dictator is pushed to a corner, it will do anything. Ultimately, it will not survive. Look at the story or the history of any dictator. Stalin died being the leader of USSR. But you know how he died? He had brain hemorrhage. And there was no doctor over there alive to treat him, because he was so paranoid that he killed, number one, all his generals and all the top doctors. And when he needed them the most, there was no one. So any kind of autocratic rule is going to perish sooner or later. But unfortunately, we still have huge part of world with the same problem, and you and I are not going to see the entire world free. That is the sad part. But democracy, being the machine it is going to do its job. It is going to have a lot of sacrifices along the way. Free people have died. And we have seen the numbers as high as millions in World War II. But somehow we have gotten ourselves better. There are some ups and downs, fluctuations, but I believe that it is going to keep on. If you look at it in the long term, it is always going to be better. Sorry for that rant, but I'm going to take few questions that were related to this very topic asked by someone. By the way, currently also there's a question by, I do not even know their names because they are saved by numbers. So it would be, Ashu is putting some questions in the group. And the question that I'm going to discuss right now is from Jayesh. He says that if World War III happens in coming years, will it wipe out humanity completely? No, it will not wipe out humanity. Now here's a bigger animal than democracy. Humanity itself. It knows how to survive. So it will reduce the population of human beings ridiculously. You might even see like 10,000, 20,000 people or 500,000 people remaining after full-on nuclear war. But they are going to continue on living. There will be places, I'm not going to take the credit because there's a tremendous video on this very topic by Infographics. I recently checked it out. And there it was mentioned that there will be certain places which will be less prone to nuclear bombs dropping. For example, southern part, South America. Africa is highly vulnerable. During World War II also there were a lot of fights over there, mainly in the northern part of Africa because of the oil. But South America is mostly peaceful. There are no major wars fought in South America. Australia was very vulnerable when the Japanese were expanding. Right. Okay. So I think that it will be a disaster. The humanity or our race will go thousands and thousands of years back. We'll have to reinvent the wheel kind of, but soon we are going to sprout out to the same population. Hopefully not doing the same dumb stuff. But we have come close to nuclear war before also, and thankfully humans were smart enough to understand that this is not going to do any good to anybody. Now looking right now at the number of countries having nuclear weapons, UK has it, France has it, United States has it, North Korea has it, Russia has it, obviously India has it, Pakistan has it. So many countries having nuclear weapons. I do not think anybody is gutsy enough or even stupid enough to do it, because everyone is going to condemn that one person who started it all. Now the first 2 atomic bombs were dropped were the first atomic bombs of the history of mankind. That was the first nuclear power that we have ever seen, even before the nuclear power plants. That was Hiroshima and Nagasaki. And after that, nobody has dared ever dropping nuclear weapons. And like I said, things have become worse before as well, where people were able to restrain themselves. When we see the full-on USSR against the United States, proxy fights going on in Vietnam, North and South Korea, and a lot of other places as well. United States has their nuclear weapons in Turkey pointed. Sorry, battery exhausted. I just realized that this has been going on for a long time. I never had so much fun in a podcast, or maybe I never expressed so much in a single podcast. So I was saying that United States had their nuclear weapons placed in Turkey, and USSR had their nuclear weapons placed in Cuba, and they're basically gun to gun on each other's face. It was a face off, but they practically walked out of it. So I still have hope for humanity, and but people do not understand that nuclear weapon is not the only problem these days. There are strict laws against nuclear weapons, and there are a lot of countries which are not even allowed to create nuclear weapons. But there are a lot of other weapons that are still there. For example, the normal chemical bombs that are still there, or normal, like what do we actually call it? I'm going to again forget the name. The basic pedigree of the original bombs, right? So if you look at whatever is the chemical inside the hand grenade itself, that chemical, obviously I'm going to put it down in the video somewhere later. TNT, sorry, yeah, I remember it. So that kind of bomb has also evolved so much in the past few years. The ballistic missiles have evolved so much that it can destroy cities, it can destroy countries. That is more than sufficient. It will not leave the land as a nuclear waste, but those weapons are sufficient to destroy cities. Even in World War II, if you look at it, the carpet bombings, complete city of Dresden in Germany was flattened. It was like nobody would even believe, if you look at it from a distance, that there used to be a city over here. So think about how much the weapons would have evolved even without the nuclear technology, right? So I'm highly doubtful and hugely faithful on the humanity that the nuclear wars will not happen. But even if it does, you and I might not survive, but humanity will. That's a bigger animal than democracy. If you are there, any chance of human life again on if yes, sorry, I'm a terrible reader. If yes, are there any chance of human life again? See, as long as the human genetics are there, right? So we have only gone back thousands of years. But if human beings go extinct, then that's a problem because that will now take thousands and thousands and millions of years to evolve from single-celled organism. And maybe we are never going to evolve the same way. Man never crosses the same river twice because it's not the same man, it's not the same river. Depends on the circumstances. So dinosaurs are extinct. We never saw dinosaurs ever again. Okay, now I think that would be more than sufficient. I'm highly impressed. I don't even think that I'm competent enough to be impressed because what people are doing in Ukraine, because they are literally fighting day and night over there. And kudos to Zelensky, who is standing over there, the forefront, unlike what we saw in Afghanistan. So it is commendable. Now, like I said, it is 26th of February. I do not know exactly what is going to happen, but what I believe is that they are going to continue on fighting. And already people are saying that Russians are behind the schedule. They wanted to take Kiev and they wanted to install a puppet government, probably Viktor Yanukovych, I do not know. And then it will obviously be pro-Russian. But it seems like it is not that easy, because even if Ukrainians are completely wiped away, there will be guerrilla warfare. Because what we know for sure right now is that Ukrainians want to fight. It is not 1939 Czechoslovakia where Hitler just walks in and people are throwing flowers. It's not happening over here. So people are fighting. They don't want Russians in, otherwise there would not be fights. And these fights are not fought by army. These are civilians who are turned into military. Some of them maybe held the gun for the first time. There was one guy, only 21 years old, says that he has shot 16 or 17 rounds only in his life, and he's alone guarding a bridge. I heard this morning that that person had to kill himself because the Russians were advancing. So obviously there's a huge division in the country, but some people still wants to fight, which means that the fight is going to continue. What I see happening is that just like there was a separatist bloc on the Eastern Front backed by Russia before, just few days before, which is crazy, there might be a separatist bloc created on the Western Front, maybe backed by West, probably backed by West, because already West is backing them with weapons and all, right? And that is what is going on. But people expected Kiev to be falling by today morning. Like I said, I was not able to sleep last night. I slept at 4:30 a.m. because I could not just stop watching what is happening. Like I said, I have gone through world wars way too much and wars way too much for my own bad, because now I'm super paranoid. I try to stay away from the news as much as possible, but this is really threatening, and I think that it is a problem that everyone should address. If it spirals out of control, nobody is going to escape and the world will burn. So it is not a small issue. Hope they solve it diplomatically. You cannot really control a set of people who really does not want to be under your thumb, so it is always going to be a problem. Maybe they are going to divide Ukraine into two parts, maybe East and West. Maybe it will be similar to similar to Germany, East Germany and West Germany. But who knows? That is another thing that you need to understand. You don't know, and I don't know. These are top military secrets. Nobody knows. Okay. Okay. But stay positive and don't go paranoid like me, which I think that I've done a poor job at. And we are going to continue more discussions regarding Spacecast. In the next one, we are going to talk about the propulsion of James Webb Space Telescope, and we are going to talk about Lagrange point. Now, since these two topics I don't think will be taking more than half an hour, you may suggest few of the topics down in the comment section, which should be discussed in the subsequent episodes, and I'm certainly going to cover. I'm going to make two independent videos. Number one focused on redshift, and the second one, there was another topic. There was something, there's a person named Global Feed who donated some money in the live. I never asked for it, but that person did and put a question in one of my live sessions. So I'm going to answer that in the next one, maybe through a video or so. But I want more topic, and after James Webb Space Telescope, there's been a lot of spacecraft stuff, and there's been a lot of orbital mechanics, there's been a lot of astrophysics. Maybe we can walk back into propulsion and maybe heavy lift launch vehicles. We have to pay attention towards the Artemis project and the Starship. Those are building up, and we certainly need to pay attention over there. And that's about it, guys. You are a great support to me, and Spacecast, I'm in total love with it. If you are in love with it, you are very, very much similar to me, because it's not only one-sided. It's not like you are in love with what I've created. It's something that is created with which I'm in love with and you're in love with, so we love them together. It's kind of a threesome. Now we are going to end it, guys. See all of you in the next one. Till then, bye.